Imagine for a second that you step out of your spaceship onto another world. The air is so thick it feels like you're being crushed by an invisible giant, or you feel winds so wild they could slice through stone. Welcome to the world of planetary atmospheres, where every breath, or the lack of one, tells a cosmic secret. Let's start this journey by picturing Venus, a place once thought to be Earth's twin. Now it's a planet wrapped in clouds thick with acid and heat that could melt metal in minutes. On the other hand, there's Mars, Earth's distant cousin, which is so cold and dry today that any water just disappears into space. Each planet's atmosphere is like a diary, filled with stories of what once was and hints at what could be. But why stop there? Let's drift farther, past the rocky worlds and into the domain of the giants. Picture Jupiter, a planet so huge that it could swallow more than 1,000 Earths. Here, storms rage for centuries and the sky might literally rain diamonds. Saturn isn't far behind, spinning with winds that carve strange shapes at its poles and rings that catch sunlight like a cosmic crown. As we move outward, things get even stranger. Uranus and Neptune, the ice giants, have atmospheres that sparkle blue thanks to frozen methane, and winds that would put any hurricane on Earth to shame. And then there's Titan, Saturn's largest moon, shrouded in a haze thicker than anything on our planet, with rivers and lakes made of liquid methane instead of water. All of these places are so different from our own world, yet they share one thing. Their atmospheres are shaped by time, by chance, and by the wild physics of the cosmos. Some once had oceans, others never stood a chance. Some hold onto their air with a tight grip, while others let it escape into the dark. And here we are, on Earth, a planet with an atmosphere just right for life. It's neither too thick nor too thin, with a perfect mix of gases and a shield that keeps us safe from the sun's harshest rays. But it wasn't always this way. Our planet's air has changed, sometimes slowly, sometimes in great leaps, shaped by volcanoes, by plants, and even by us. So as we set off to explore the wild skies of our solar system, keep in mind that every world has its own story. Some are warnings, others are mysteries, and all of them help us understand just how rare and precious our own home really is. Before we launch into this adventure, hit that like button and subscribe to Exploring the Universe. You won't want to miss any of the cosmic discoveries ahead. So, are you ready to take this interplanetary journey with me? Let's go. You're standing on the surface of what looks like Earth's twin sister. Same size, same rocky composition, orbiting roughly the same distance from the Sun. But the moment you step outside your spacecraft, you'd be crushed like an empty soda can and simultaneously cooked alive. Welcome to Venus, where the atmosphere has gone completely rogue. Venus should have been our planetary sibling, maybe even our backup home. Instead, it became a cautionary tale written in sulfuric acid clouds and crushing atmospheric pressure. The air pressure there is 92 times heavier than what we experience on Earth. Imagine carrying 92 times your body weight on your shoulders while being slowly roasted at temperatures hot enough to melt lead pipes. But here's where the story gets really fascinating. Venus wasn't always this hellish furnace. Scientists believe it once had oceans, maybe even conditions suitable for life. So what went wrong? The answer lies in one of the most dramatic examples of climate change in our solar system. Venus fell victim to a runaway greenhouse effect that turned paradise into purgatory. The trouble started with carbon dioxide. As Venus received slightly more solar energy than Earth, its oceans began to evaporate. Water vapor, being a greenhouse gas, trapped more heat, which caused more evaporation, which trapped even more heat. It was like a cosmic feedback loop spinning completely out of control. Eventually, all the water escaped to space, leaving behind a dense atmosphere of carbon dioxide that acts like a planetary pressure cooker. The clouds floating above Venus aren't the fluffy white cotton balls we see on Earth. They're made of concentrated sulfuric acid, the same stuff that can eat through metal. These acid clouds reflect so much sunlight that Venus actually appears brighter than any star in our night sky, earning it the nickname the morning star or the evening star, depending on when you spot it. Here's a mind-blowing fact that really puts Venus's hostility into perspective. Back in the 1980s, The Soviet Union sent a series of brave little probes to Venus's surface. These weren't cheap missions either. They were heavily armored, built like tanks, designed to withstand the most extreme conditions engineers could imagine. Yet even these metal warriors barely survived 2 hours before the crushing atmosphere and scorching heat turned them into expensive scrap metal. The temperature on Venus hovers around 860 degrees Fahrenheit, which is hot enough to melt zinc coins in your pocket. And here's the kicker. It's the same temperature everywhere on the planet. Day, night, equator, poles. It doesn't matter. The thick atmosphere distributes heat so effectively that Venus has no seasons, no daily temperature changes, no relief zones. It's just consistently, relentlessly hot. But perhaps the most sobering aspect of Venus's story is what it tells us about our own planet. Some scientists view Venus as a glimpse into Earth's possible future if we're not careful with our own greenhouse gas emissions. While we're nowhere near Venus's extreme situation, the basic physics are the same. Add too much carbon dioxide to an atmosphere, and you risk triggering changes that become impossible to reverse. Venus serves as both a scientific treasure and a cosmic warning. It shows us how quickly a planet can transform from potentially habitable to absolutely lethal. In the grand story of our solar system, Venus plays the role of the cautionary character, the one whose fate makes us appreciate just how precious and fragile our own atmospheric balance truly is. Imagine walking through an ancient riverbed on Mars, your boots crunching on dried sediment that once flowed with rushing water. You can see the carved valleys, the delta formations, even what looks like ancient shorelines. But as you try to take a breath, you realize there's almost nothing there to breathe. Mars is like a ghost town in space, haunted by the memory of what it used to be. Billions of years ago, Mars was a completely different world. Rivers carved through its landscape, lakes sparkled under a thicker atmosphere, and some scientists even believe early microbial life might have thrived in its warmer, wetter environment. But something catastrophic happened that transformed this potentially habitable world into the cold, nearly airless desert we see today. The story of Mars's atmospheric collapse reads like a cosmic tragedy. Deep inside the planet, its molten core began to cool and slow down. This might sound like a minor detail, but it triggered a chain reaction that doomed the entire planet. When Mars's core stopped spinning vigorously, it could no longer generate the magnetic field that had been protecting the planet like an invisible shield. Think of a magnetic field as Earth's cosmic bodyguard. It deflects harmful solar wind, those streams of charged particles constantly blasting out from the sun. Without this protection, Mars became defenseless against this stellar assault. For millions of years, solar winds gradually stripped away Mars's atmosphere, particle by particle, until almost nothing remained. Here's a way to picture the dramatic difference. If Earth's atmosphere were a thick, comfortable mattress that cushions and protects us, Mars's atmosphere would be like a silk bedsheet, so thin you can barely feel it's there. The atmospheric pressure on Mars is less than 1% of what we experience on Earth. It's so thin that if you poured a glass of water on Mars's surface, it would instantly boil away into space, not because it's hot, but because there's simply not enough atmospheric pressure to keep it liquid. This atmospheric thinness creates some bizarre phenomena. Dust storms on Mars can cover the entire planet and last for months. Yet if you were standing in the middle of one, you'd barely feel a breeze. The air is so thin that even hurricane-force winds on Mars would feel like a gentle push. It's like being in a snow globe where all the snow is swirling around dramatically, but there's no substance behind it. The temperature swings on Mars are equally extreme. Without a thick atmosphere to regulate heat, Mars can go from a relatively mild 70 degrees Fahrenheit at the equator during summer to minus 190 degrees Fahrenheit at the poles during winter. It's like living in a place where you might need a light jacket at noon and a spacesuit by evening. But here's what makes Mars's story particularly fascinating for us. Scientists have found evidence that this atmospheric loss is still happening today. NASA's MAVEN spacecraft has been watching solar wind continue to peel away what's left of Mars's thin atmosphere. It's like witnessing a very slow-motion catastrophe that's been unfolding for billions of years. The most haunting aspect of Mars's tale is how it makes us think about our own planet's future. Earth's magnetic field protects us just as Mars's once protected it. While our magnetic field is currently strong and stable, geological records show it has weakened and even reversed in the past. Could Earth eventually face the same fate as Mars? It's a sobering thought that adds urgency to our efforts to understand and protect our own atmospheric sanctuary. Mars serves as a powerful reminder that planets aren't permanent. They're dynamic, changing worlds where small changes deep inside can have massive consequences for everything on the surface. In the grand story of our solar system, Mars plays the role of the fallen hero, showing us both what we've lost and what we still have to protect. Picture the most violent storm you've ever witnessed on Earth. Maybe it was a hurricane that left you without power for days, or a tornado that made you take shelter in your basement. Now multiply that fury by 1,000 and stretch it across an area larger than our entire planet. Welcome to Jupiter, where weather doesn't just happen, it becomes immortal. Jupiter is like that friend who never calms down, never takes a break, never stops being absolutely magnificently chaotic. While Earth's biggest hurricanes last maybe a week or two before they exhaust themselves, Jupiter hosts storms that have been raging for centuries. The Great Red Spot, Jupiter's most famous tempest, has been spinning continuously for at least 400 years. That storm was already old when Shakespeare was writing his plays, and it's still going strong today. But here's where Jupiter gets really mind-bending. This isn't just a big planet with big storms. Jupiter doesn't even have what we'd recognize as a surface. If you could somehow survive the crushing pressure and toxic atmosphere, and you tried to land on Jupiter, you'd just keep falling. Forever. There's no solid ground waiting for you down there. Just layers upon layers of increasingly compressed gas that eventually become so dense they turn into liquid, and then into something even stranger. Metallic hydrogen. Imagine hydrogen, the lightest element in the universe, squeezed so hard that it starts behaving like liquid metal. That's what happens deep inside Jupiter. The pressure down there is so intense that it would instantly flatten any material we know how to make. It's like nature took the normal rules of physics and decided to write a completely new playbook. The winds on Jupiter make Earth's most powerful hurricanes look like gentle breezes. We're talking about atmospheric rivers moving at 600 kilometers per hour. That's faster than most commercial airplanes fly. These winds don't just blow around dust and debris like they do on Earth. On Jupiter, they're moving entire atmospheric layers that are thicker than our planet's diameter. And then there's the diamond rain. Yes, you heard that right. Scientists believe that deep in Jupiter's atmosphere, the extreme pressure and temperature conditions actually create diamonds that fall like raindrops. Not tiny sparkles, but chunks of crystallized carbon tumbling through an alien sky. It sounds like something out of a fantasy novel, but it's real physics happening on a scale that makes our imagination look small. The famous astronomer Carl Sagan once said something that really captures Jupiter's terrifying majesty. If there is a hell in the solar system, it is in the interior of Jupiter. He wasn't being dramatic for effect. He was describing a place where the very atoms get crushed into forms that don't exist anywhere else we know of. Jupiter's atmosphere is essentially a laboratory for extreme physics. Scientists study it not just to understand this one planet, but to learn about conditions that might exist around other stars, in the cores of planets we'll never visit, and in the early universe when everything was much more violent and compressed than it is today. The most fascinating part might be that Jupiter's chaos actually protects us. This giant storm world acts like a cosmic vacuum cleaner, using its massive gravity to capture asteroids and comets that might otherwise crash into Earth. Jupiter's eternal tempests aren't just beautiful and terrifying. They're literally keeping us safe while they rage. Every time we look at Jupiter through our telescopes, we're watching a planet-sized engine of creation and destruction that never sleeps, never rests, and never stops reminding us just how calm and gentle our own little blue world really is. If you think nature doesn't have a sense of humor, then you haven't met Saturn. This is the planet that decided to wear the most spectacular jewelry in the solar system while simultaneously carving a perfect geometric shape at its north pole that has scientists scratching their heads and double-checking their instruments. Let's start with Saturn's most famous feature, those incredible rings. From Earth, they look like a simple disk around the planet, elegant and smooth. But when you get closer, you realize you're looking at billions upon billions of chunks of ice and rock. each one orbiting Saturn like a tiny moon. Some pieces are as small as grains of sand, others as big as mountains. They're all dancing together in a cosmic ballet that's been going on for millions of years, creating what might be the most beautiful sight in our solar system. But Saturn's real mystery lies at its North Pole, where something absolutely bizarre is happening. Picture this: a perfectly formed hexagon, spinning in Saturn's atmosphere like someone drew it with a cosmic compass. This isn't some fuzzy, almost hexagonal shape that we're squinting at and hoping to see. This is a sharp, clearly defined six-sided figure that's 4 times wider than Earth itself. When scientists first spotted this hexagon back in the 1980s, many thought their instruments were broken. Geometric shapes this perfect simply don't appear in nature, especially not on the scale of entire planets. Yet there it was, and there it remains today, spinning away like a giant celestial stop sign that's been frozen in Saturn's clouds. The hexagon has been rotating steadily for decades now, and here's what makes it even more puzzling. It rotates at exactly the same speed as Saturn's interior. That suggests this atmospheric feature is somehow connected to the planet's core, spinning in perfect synchronization with the solid parts of Saturn that we can't even see. Scientists have come up with several theories to explain this cosmic riddle. Some think it might be a standing wave pattern, where Saturn's rotation creates a stable geometric shape in its atmosphere the same way water forms patterns when you vibrate a container. Others believe we might be witnessing something completely new to science, an atmospheric phenomenon that doesn't exist anywhere else we know of. What makes Saturn even more fascinating is that while Venus burns and Mars freezes, Saturn presents us with this perfect hexagon puzzle wrapped in an atmosphere that's actually more dynamic than Jupiter's. The winds on Saturn move even faster than Jupiter's legendary storms, reaching speeds that would make our most powerful hurricanes look like gentle summer breezes. Saturn's atmosphere is mostly hydrogen and helium, just like Jupiter's, but it's arranged in a completely different way. Instead of Jupiter's chaotic swirling bands, Saturn shows us these incredibly organized, almost architectural patterns. It's like comparing a Jackson Pollock painting to a perfectly planned city grid. The hexagon itself sits above a massive hurricane at Saturn's North Pole. This storm is larger than Earth, spinning counterclockwise while the hexagon rotates around it. Imagine a hurricane so big that you could drop our entire planet into its eye. And then imagine a geometric frame spinning around the whole thing. It sounds like science fiction, but it's happening right now, about 1 billion miles away from us. Here's something that really captures how strange this is. We've found hexagonal patterns in nature before, like in snowflakes or honeycomb structures, but those happen on tiny scales because of molecular forces. Saturn's hexagon exists on a planetary scale, where the physics should be completely different. It's like finding a perfectly carved sculpture in the middle of a raging ocean. Some researchers wonder whether this kind of geometric atmospheric pattern might exist on other planets around other stars. Maybe Saturn isn't unique. Maybe there are worlds out there with triangular poles, or square storm systems, or atmospheric patterns we haven't even imagined yet. The most intriguing possibility is that Saturn's hexagon might be teaching us something fundamental about how atmospheres work, something we never would have discovered just by studying Earth. Every time we think we understand how planets behave, Saturn shows up with its geometric weather and reminds us that the universe is far stranger and more beautiful than we ever expected. You're floating through the outer reaches of our solar system, where sunlight is so faint it barely warms anything at all. Here, in this cosmic deep freeze, live 2 mysterious worlds that challenge everything we thought we knew about planets. Meet Uranus and Neptune, the ice giants that are rewriting the rules of planetary science. These aren't your typical gas giants like Jupiter and Saturn. No, these distant worlds are something entirely different, something that makes scientists scratch their heads and wonder how nature pulled off such incredible tricks. Both planets are wrapped in atmospheres so strange and beautiful that they seem almost magical. Let's start with their signature blue glow. Both Uranus and Neptune shine with this ethereal, almost hypnotic blue light that makes them look like cosmic sapphires floating in the darkness. This isn't just pretty to look at. It's the result of methane gas in their atmospheres doing something absolutely fascinating. When sunlight hits these planets, the methane molecules absorb all the red wavelengths and bounce back only the blue ones. It's like having a planetary-sized color filter that transforms ordinary sunlight into this stunning azure radiance. But here's where things get really wild. The methane in these atmospheres doesn't just create pretty colors, it actually freezes into tiny crystals that float around like cosmic snowflakes. Imagine clouds made of frozen methane instead of water vapor, drifting through an atmosphere so cold that most substances we know would instantly turn solid. These methane crystals catch and reflect light in ways that create some of the most beautiful atmospheric displays in our solar system. Neptune holds the record for something that seems completely impossible. Remember, this planet sits about 30 times farther from the Sun than Earth does. It receives almost no solar energy at all. Logic tells us that a world this far from our star should be a frozen, dead place with barely any atmospheric activity. Instead, Neptune hosts the most violent winds in the entire solar system, gusts that reach 2,100 kilometers per hour. To put that in perspective, these winds are faster than bullets fired from most rifles. They're so powerful, they could literally tear apart anything we might try to send there. But here's the mystery that keeps planetary scientists awake at night. Where does all this energy come from? Neptune generates more heat internally than it receives from the Sun, but we still don't fully understand how a planet can maintain such incredible atmospheric violence with so little external energy input. The story gets even stranger when we dig deeper into what these planets might be hiding beneath their atmospheric layers. Scientists believe that deep inside both Uranus and Neptune, the extreme pressure and temperature conditions might create something that sounds like science fiction. Oceans of liquid diamond. Think about it for a moment. The carbon in these planets gets squeezed and heated to such incredible extremes that it transforms into diamond crystals. But instead of forming solid structures like the diamonds we know on Earth, these conditions might create actual seas of liquid diamond, flowing and churning in the planetary depths. It's like having treasure chambers the size of continents, filled with the most precious substance we know, completely inaccessible to us, but probably existing right now, billions of kilometers away. Uranus adds another layer of mystery to this cosmic puzzle. Unlike every other planet in our solar system, Uranus spins on its side. Something massive must have smashed into it long ago, knocking it over like a cosmic bowling pin. This sideways rotation creates the strangest seasons imaginable. Each pole experiences 42 years of continuous daylight, followed by 42 years of total darkness. Imagine living through a winter night that lasts 4 decades, followed by a summer day that goes on just as long. The atmospheric dynamics this creates are unlike anything else we've observed. Weather patterns that take human lifetimes to complete, temperature differences that shift over geological timescales, and wind systems that operate according to rules we're still trying to figure out. Both planets challenge our understanding of how worlds form and evolve. They're too massive to be rocky planets like Earth and Mars, but too small and too far from the Sun to be gas giants like Jupiter and Saturn. They represent a completely different category of world, one that might actually be the most common type of planet in our galaxy. Recent discoveries have shown that planets similar to Uranus and Neptune exist around other stars throughout the Milky Way. This means these strange, beautiful ice giants might not be cosmic oddities at all. They might be showing us what most planets in the universe actually look like. Cold, mysterious worlds wrapped in exotic atmospheres where familiar substances behave in completely unfamiliar ways. The more we study Uranus and Neptune, the more they remind us that our solar system still holds incredible secrets. These distant giants prove that even in our own cosmic neighborhood, there are worlds so alien and wonderful that they stretch our imagination and challenge our understanding of what's possible in this universe. Imagine stepping off a spacecraft onto what looks like a familiar world. There's a thick atmosphere above you, clouds drifting across an orange sky, and in the distance you can see what appear to be rivers winding through landscapes toward vast lakes. For a moment, you might think you've landed on some distant version of Earth, but then reality hits. Those rivers aren't flowing with water, they're streaming with liquid methane and ethane. Those lakes aren't filled with anything you could drink, they're brimming with hydrocarbons that would power your car for years. Welcome to Titan, Saturn's largest moon, and perhaps the most Earth-like yet utterly alien world we've discovered. Titan is the only place in our solar system besides Earth where you could stand on the surface without a pressure suit. Not that you'd want to try it without protection. The air is unbreathable and the temperature hovers around minus 180 degrees Celsius. But the atmospheric pressure is actually slightly higher than what we experience on Earth, which means your blood wouldn't boil and your body wouldn't explode like it would on Mars or in the vacuum of space. The atmosphere itself tells an incredible story. It's almost entirely nitrogen, just like Earth's, but with a crucial difference. Instead of oxygen making up the remaining 20%, Titan's air contains methane and other organic compounds. This creates something that scientists call a prebiotic environment, a chemical laboratory where the building blocks of life might naturally form even without life itself being present. Here's where Titan gets really fascinating. The methane in its atmosphere behaves exactly like water does on Earth. It evaporates from the lakes, rises into the atmosphere, condenses into clouds, and falls back down as rain. But we're talking about methane rain, liquid natural gas dropping from alien clouds onto a world where the rivers and lakes are filled with the same stuff we use to heat our homes and power our vehicles. The Cassini spacecraft, which spent 13 years studying Saturn and its moons, gave us our first detailed look at this incredible world. The images it sent back showed landscapes that looked hauntingly familiar yet completely alien. There are river networks that meander across Titan's surface just like the Amazon or Mississippi, carving channels and creating deltas where they flow into larger bodies of liquid. There are coastlines with what appear to be beaches, except those beaches are made of water ice as hard as rock, and the waves lapping against them are made of methane. The largest of these hydrocarbon seas, called Kraken Mare, is bigger than the Caspian Sea on Earth. It's so vast that if you stood on one shore, you wouldn't be able to see the other side even on the clearest day. Scientists believe these seas might be hundreds of meters deep, creating underwater landscapes we can only imagine. Picture underwater mountains and valleys, all submerged beneath liquid methane instead of water. But Titan's story gets even more intriguing when we consider what might be happening beneath its surface. Just like Jupiter's moon Europa and Saturn's moon Enceladus, Titan likely harbors a subsurface ocean of liquid water beneath its icy crust. This means Titan might actually have two completely different environments where life could potentially exist: the exotic hydrocarbon chemistry happening on its surface and a more familiar water-based environment hidden below. The possibility of life on Titan forces us to expand our thinking about what life might look like. We're used to thinking about life as something that requires liquid water, but Titan raises the question, could there be organisms that use liquid methane the way Earth life uses water? Could there be some form of metabolism based on the complex organic chemistry happening in those hydrocarbon lakes? This is exactly what NASA's upcoming Dragonfly mission aims to explore. Set to launch in the 2030s and arrive at Titan in the 2040s, Dragonfly will be unlike any space mission we've ever attempted. It's essentially a nuclear-powered drone that will fly around Titan's surface, landing at different locations to study the moon's chemistry and search for signs of life. The fact that we can send a flying vehicle to explore Titan speaks to just how remarkable this world is. The thick atmosphere provides enough air density for flight, while the low gravity, about 1/7 of Earth's, makes it even easier for aircraft to stay aloft. Dragonfly will be able to cover distances that would take ground-based rovers years to traverse, hopping from one fascinating location to another like a robotic bird exploring an alien world. What makes Dragonfly's mission so exciting is that Titan might preserve a record of the chemical processes that led to life on Earth. 4 billion years ago, our planet's atmosphere was very different from today. It contained methane and other organic compounds similar to what we see on Titan now. By studying Titan's chemistry, we might be looking at a frozen-in-time version of early Earth, a natural laboratory showing us how the complex molecules necessary for life might first come together. The more we learn about Titan, the more it challenges our assumptions about where life might exist in the universe. It's a world where the familiar and the alien blend together in ways that stretch our imagination. Rivers and lakes that look like home, but are made of completely different substances. Weather patterns that mirror Earth's, but operate with chemicals that would be explosive in our atmosphere. An environment that might harbor life, but life so different from what we know that we might not even recognize it at first. Titan reminds us that the universe is far more creative and surprising than we often give it credit for. In our search for life beyond Earth, we've learned not to look just for worlds that are exactly like ours, but for worlds that might support life in ways we haven't yet imagined. And in that search, Titan stands out as one of the most promising and mysterious destinations we've found. A place where science fiction and science fact merge into something even more wonderful than either could be alone. Picture the closest planet to our Sun, a world so close that it completes an entire orbit in just 88 Earth days. You might expect Mercury to have a thick, substantial atmosphere to help it deal with the Sun's intense radiation. Instead, Mercury holds one of the most surprising atmospheric secrets in our solar system. It barely has any air at all. What Mercury possesses isn't really an atmosphere in the way we understand it. Scientists call it an exosphere, which is essentially the thinnest possible layer of gas that can still technically count as an atmosphere. Imagine trying to breathe air so thin that individual atoms are more likely to escape into space than bump into each other. That's Mercury's reality. The story of Mercury's missing atmosphere begins with its proximity to our star. While Earth sits comfortably 93 million miles from the Sun, Mercury orbits at just 36 million miles away. At that distance, the Sun doesn't just provide warmth, it becomes a cosmic blow-dryer set to maximum power. Solar radiation is so intense that it literally blows away any substantial atmosphere that might try to form. But here's where Mercury's story takes a fascinating turn. Despite having almost no air, this little planet manages to create its own unique atmospheric cocktail through some truly remarkable processes. The ingredients come from the most unexpected sources: meteorite impacts and solar wind bombardment. When tiny space rocks slam into Mercury's surface, they knock loose atoms of sodium, potassium, calcium, and other elements. These atoms get kicked up into the planet's thin exosphere, creating an incredibly sparse but measurable atmosphere. It's like Mercury is constantly being sandblasted by space debris, and each impact adds a few more atoms to its wispy air. The solar wind plays an equally important role in this atmospheric drama. High-energy particles streaming from the Sun don't just strip away atmosphere, they also interact with Mercury's surface rocks, liberating more atoms that join the planet's thin gaseous envelope. It's a cosmic recycling program where the very force that prevents a thick atmosphere from forming also helps create the thin one that exists. Now here's the truly mind-blowing part about Mercury's atmospheric story. This planet actually has a tail, just like a comet. Scientists discovered that Mercury's sparse atmosphere gets swept away by solar pressure, creating a stream of sodium atoms that extends for thousands of miles behind the planet as it orbits the Sun. Mercury literally leaves a glowing trail of its own atmosphere as it races around our star. The composition of Mercury's exosphere reads like a chemistry textbook. Sodium, potassium, calcium, magnesium, hydrogen, helium, and oxygen, all floating around in concentrations so low that the entire atmospheric pressure is about 1 trillion times weaker than Earth's. If you could somehow stand on Mercury's surface, you wouldn't be able to breathe, not just because there's no oxygen in useful quantities, but because there's essentially no pressure at all. This atmospheric fragility creates some of the most extreme temperature swings in the solar system. Without a substantial atmosphere to distribute heat, Mercury's day side can reach temperatures of 800 degrees Fahrenheit, hot enough to melt zinc, while its night side plunges to minus 300 degrees Fahrenheit, colder than the surface of Pluto. The lack of atmospheric insulation means Mercury experiences a temperature difference of over 1,000 degrees between its day and night sides. The story of Mercury's barely there atmosphere offers profound insights into planetary evolution. It shows us what happens when a world sits too close to its star, demonstrating the delicate balance required for atmospheric retention. Mercury's situation helps scientists understand why some exoplanets might be airless rocks, despite being in potentially habitable zones around their stars. Mercury serves as a cosmic laboratory for studying extreme atmospheric conditions. Its exosphere represents the absolute minimum of what can still be called a planetary atmosphere, a boundary case that helps define the limits of atmospheric science. In the grand narrative of our solar system, Mercury plays the role of the stripped-down survivor. a world that shows us how planets can endure, even when they've lost almost everything we associate with having air to breathe. Take a deep breath right now. Feel that air filling your lungs? You've just experienced one of the most remarkable and unlikely phenomena in the known universe. Earth's atmosphere isn't just special. It's a cosmic miracle that exists in such a narrow range of conditions that even tiny changes could make our planet as lifeless as Venus or as barren as Mars. Our atmospheric recipe seems deceptively simple. Roughly 78% nitrogen, 21% oxygen, and less than 1% of everything else, including that crucial trace of carbon dioxide and water vapor. But this mixture represents billions of years of planetary fine-tuning, biological evolution, and sheer cosmic luck. It's like having the perfect recipe for a cake where changing any ingredient by even a small amount would result in complete disaster. The story of Earth's atmosphere begins over 4 billion years ago, when our planet was a hellish world of molten rock and toxic gases. The early atmosphere was nothing like what we breathe today. It was a choking blend of methane, ammonia, carbon dioxide, and water vapor, with virtually no oxygen at all. Any time traveler visiting Earth back then would need a gas mask and heat-resistant suit to survive even moments on the surface. Then came one of the most revolutionary events in planetary history, the rise of cyanobacteria, tiny organisms that learned to harness sunlight through photosynthesis. These microscopic pioneers began pumping oxygen into the atmosphere as a waste product. At first, this oxygen was actually toxic to most life forms that existed at the time. It triggered what scientists call the Great Oxidation Event, a planetary transformation so dramatic that it caused the first mass extinction in Earth's history. But life adapted, as it always does, and oxygen became the foundation for more complex forms of life. Over millions of years, plants and algae continued this atmospheric engineering project, maintaining the delicate balance between oxygen production and carbon dioxide absorption that makes our world habitable. Here's where the story gets truly remarkable. Earth's atmosphere acts like a cosmic life support system with multiple backup mechanisms. The ozone layer, made of 3 oxygen atoms bonded together, forms a protective shield in the upper atmosphere that blocks deadly ultraviolet radiation from the sun. Without this invisible guardian, life on Earth's surface would be impossible. The discovery of ozone holes in the 1980s reminded us just how fragile this protection really is. Our atmosphere also serves as a planetary thermostat through the greenhouse effect. Yes, the same process that's turning Venus into a furnace actually keeps Earth warm enough for liquid water to exist. Carbon dioxide and water vapor trap just enough heat to prevent our oceans from freezing solid, but not so much that we become a boiling wasteland. It's a balance so precise that scientists sometimes call it the Goldilocks effect. Not too hot, not too cold, but just right. The magnetic field generated by Earth's molten iron core adds another layer of protection that many people don't realize is crucial for our atmosphere. This invisible shield deflects most of the solar wind, preventing our atmosphere from being slowly stripped away like what happened to Mars. Without this magnetic umbrella, Earth might have lost its air to space billions of years ago. But perhaps the most sobering aspect of Earth's atmospheric story is how quickly this balance can shift. Venus likely started with conditions similar to Earth's, with liquid water and a moderate climate. However, a runaway greenhouse effect transformed it into the acid-clouded inferno we see today. Some scientists estimate that Venus's transformation from potentially habitable to absolutely lethal took less than a few 100 million years, which is remarkably quick in geological terms. Climate scientists today study ice cores, ancient tree rings, and fossil records to understand how Earth's atmosphere has changed over time. They've discovered that our climate system can sometimes shift dramatically within just decades or centuries. The medieval warm period, the Little Ice Age, and other natural climate variations show us that even without human influence, Earth's atmospheric balance is constantly shifting. The rise of human civilization has added a new chapter to this atmospheric story. Since the Industrial Revolution began in the 18th century, we've been conducting an unintended global experiment by adding greenhouse gases to the atmosphere at unprecedented rates. We're essentially testing how much we can alter our atmospheric recipe before triggering changes that become impossible to reverse. What makes Earth's atmosphere truly extraordinary isn't just its current composition, but its ability to maintain stability through biological and geological feedback loops. When volcanic eruptions add carbon dioxide, oceans and plants absorb more of it. When ice ages lock up water, the remaining oceans become more effective at regulating temperature. These natural balancing mechanisms have kept our planet habitable through asteroid impacts, massive volcanic eruptions, and other cosmic catastrophes. Yet this same atmosphere that has nurtured life for billions of years remains incredibly fragile. The total mass of our entire atmosphere is equivalent to just a thin skin around our planet. If Earth were the size of an apple, our breathable atmosphere would be thinner than the apple's peel.
This perspective makes it clear why protecting our atmospheric balance isn't just an environmental concern. It's a matter of cosmic responsibility. Earth's atmosphere represents the only known example in the universe of air that can sustain complex life. In a cosmos filled with toxic gases, crushing pressures, and airless rocks, our planet's gentle breeze carrying the scent of flowers and the songs of birds stands as proof that the impossible can happen.
The question that haunts scientists and philosophers alike is whether this atmospheric miracle is unique to Earth, or if somewhere among the trillions of worlds in the universe, other planets have managed to achieve their own improbable balance of life-giving air. Standing here on Earth, breathing this perfect mixture of nitrogen and oxygen, it's easy to forget that we're living inside one of the most remarkable success stories in the known universe. Every breath we take connects us to a cosmic narrative that spans billions of years and countless worlds, each with its own atmospheric tale to tell. Think about what we've discovered on this journey through our solar system's skies. Venus stands as a stark warning about how quickly paradise can become hell. Once, this planet might have had oceans and gentle breezes, but today it serves as a cautionary tale written in sulfuric acid clouds. Its crushing atmosphere whispers to us about the delicate balance between life and death, between a world that nurtures and one that destroys. When we study climate change on our own planet, Venus haunts our calculations, reminding us that runaway greenhouse effects aren't just theoretical possibilities, but real fates that befall worlds. Mars tells a different but equally sobering story. It shows us what happens when a planet loses its shield, when the very air that once supported rivers and lakes gets stripped away particle by particle until almost nothing remains. Walking through ancient Martian riverbeds with our rovers, we're essentially exploring a graveyard of possibilities, seeing what Earth might have become if our magnetic field had failed or our core had cooled too quickly. Mars doesn't just teach us about atmospheric loss, it teaches us about cosmic vulnerability. Then we venture into the realm of the gas giants, where nature reveals its most creative and terrifying aspects. Jupiter's eternal storms show us weather systems that dwarf our entire planet, tempests that have raged longer than human civilization has existed. These atmospheric monsters remind us that Earth's gentle seasons and manageable hurricanes are gifts we should never take for granted. Saturn adds its own twist to this cosmic drama, with that mysterious hexagon spinning at its pole, proving that the universe still holds secrets that challenge our understanding of atmospheric physics. The ice giants, Uranus and Neptune, push the boundaries of what we consider possible. Worlds where it might rain diamonds, where methane crystals float like cosmic snow, where winds race faster than bullets through atmospheres so cold that most substances would instantly freeze solid. These distant worlds expand our definition of what an atmosphere can be, showing us that nature is far more creative than any science fiction writer could imagine. And then there's Titan, Saturn's remarkable moon that forces us to completely reimagine what a habitable world might look like. Here's a place with rivers and lakes and rain, but where everything we consider familiar is made of substances we use to fuel our cars. Titan challenges our Earth-centric view of habitability, suggesting that life might find ways to thrive in environments we never would have considered possible. Even Mercury, seemingly the least atmospheric world we've explored, teaches us valuable lessons about planetary survival. Its thin exosphere, created by cosmic bombardment and solar wind, shows us the absolute minimum of what can still be called an atmosphere. Mercury reminds us that even in the most extreme conditions, Planets find ways to maintain some connection to the cosmic environment around them. Each of these worlds serves as both a laboratory and a library, storing information about planetary evolution, atmospheric chemistry, and the countless ways that worlds can develop and change over time. They're not just distant objects to study. They're chapters in a cosmic story that helps us understand our own place in the universe. Perhaps the most profound lesson from this atmospheric tour is how extraordinary Earth's balance truly is. Our planet didn't just accidentally stumble into the perfect atmospheric mixture. It earned this balance through billions of years of geological activity, biological evolution, and cosmic fortune. The oxygen we breathe was once toxic waste produced by ancient bacteria. The ozone layer that protects us formed gradually as life itself changed the chemistry of our world. The magnetic field that shields our atmosphere continues to operate thanks to processes deep in our planet's core that we're still working to understand fully. This atmospheric story isn't just about the past, it's about the future too. As we develop better telescopes and space missions, we're beginning to study the atmospheres of planets around other stars. Each exoplanet atmosphere we analyze adds new chapters to this cosmic library, helping us understand whether Earth-like conditions might exist elsewhere in the galaxy. The James Webb Space Telescope has already begun detecting water vapor, carbon dioxide, and other atmospheric components on distant worlds. Some of these exoplanets might have skies filled with iron clouds or rain made of molten glass. Others might harbor atmospheric conditions similar to ancient Earth or present-day Venus. Every new discovery expands our understanding of what's possible in the cosmic arena of atmospheric evolution. But perhaps the most important message from studying planetary atmospheres is how precious and fragile our own atmospheric balance really is. Venus shows us what happens when greenhouse effects spiral out of control. Mars demonstrates the consequences of losing atmospheric protection. The gas giants reveal the raw power of uncontrolled atmospheric dynamics. And Earth stands as proof that somewhere between these extremes, conditions can align to create something truly miraculous. Our atmosphere is more than just the air we breathe. It's a protective bubble that has nurtured the evolution of life for billions of years. It's a cosmic accident that became a biological necessity. It's a delicate balance that continues to maintain itself through complex interactions between living organisms, geological processes, and astronomical forces. Every time we look up at the sky, we're seeing the thin boundary between our life-supporting world and the vast, often hostile cosmos beyond. That blue dome above us represents one of the most successful atmospheric experiments in the known universe, a 4.5 billion-year project in planetary engineering that continues to evolve with each passing day. The stories written in planetary atmospheres remind us that we're not just observers of the cosmos, we're participants in it. Our activities on Earth are now influencing our atmospheric composition in ways that will determine what kind of world future generations inherit. The lessons from Venus, Mars, and the other worlds we've explored aren't just scientific curiosities. They're guidebooks for understanding how to maintain the atmospheric miracle that makes our existence possible. In the end, each atmosphere tells us a story about possibility, about resilience, and about the incredible creativity of natural processes operating on planetary scales. They remind us that in a universe filled with airless rocks and toxic clouds, our gentle earth breeze carrying the scent of flowers and the promise of rain represents something truly extraordinary. These atmospheric tales don't just teach us about other worlds, they teach us to treasure the one world we call home.